Okay, so on this lesson, we're going to be looking at solving linear and quadratic systems. Remember, systems, you have two or more equations. So we're going to have a system that consists of one linear equation and one quadratic equation. You should know what those look like on a graph. Linear is a straight line, quadratic is a parabola. We've gone over both of them. So whenever you're solving a linear quadratic system, it may have two solutions, which will look like this. There's two here because they're intersecting at two different places. And then there'll be one solution if it looks similar to this. It only crosses the parabola once. And then you have no real solution if you have a parabola with a line that does not cross through it. Okay, so we're going to be using a calculator. So we're going to be graphing and then finding where they're intersecting. When you solve a system, you're trying to find the points that they have in common. So on your calculator, we're going to type in Y1, we're going to type in this first quadratic. So you'll need to go to your calculator, go to Y equals, type in the first one. And then you'll go to Y2, type in the second one into your Y2. So you're typing in both of them into Y equals on the calculator. And then whenever you press graph, you're going to see that there is a parabola that crosses a linear equation twice, and you're going to find the point of intersection. So after you've plugged these two into Y equals, you're going to do second calc, and you're going to choose number 5, which we're used to. That's intersect. We're trying to find where the parabola intersects the linear equation. And notice on this one, you're going to be having two solutions or two intersection points. So you'll have to do it twice. So if you do second calc number 5, enter, 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 you should get 1, -4 for one of your intersection points. Now you have to repeat those steps to find the other one. And you'll have to move your cursor to the other intersection point before you press enter 3 times. And then enter, enter times 3. Okay? When you do that, your other intersection point for this example should be -4, 6. So let's go ahead and plot those. So we have a parabola that looks similar to this, and then we have a linear line that looks similar to this. So you're trying to find the points that they have in common. So your solutions are the points of intersection. So that's the solution we're looking for there. So when you're solving a system, remember you're trying to find the points they have in common. So again, you're using a calculator. You're typing in one of them in Y2. It doesn't matter which one, the other one in Y2. And then you're finding second calc intersect. You'll have to repeat and move your cursor to the other one before you can find that second one. Okay, let's look at example 2. So on this one, notice that it doesn't have Y equals. So we'll have to adjust our two equations in order to get it in Y equals form. So I'm looking at this one. I'm just going to write it down. I'm going to get Y by itself so I can use a calculator to plug it in. Notice I have a -Y, so I'll need to divide everything by -1. Make sure you do it by everything, so that way it becomes +Y. That'll make it +X and +5. So there's my linear one. It doesn't matter which one you plug in because you're having to plug both of them in. So I'll call that one Y1. And looking at my second one, I'm going to get Y by itself. Divide everything by 2. And that's a -1 in front, so -1/2 x squared plus 9. So make sure you divide both of them. So I'll plug this into Y2. Okay, so go to your Y equals on your calculator. You're going to type in x plus 5 in Y1. You're going to type in -1/2 x squared plus 9 in Y2. and you're going to graph it. So remember, once you've pressed graph, you're going to do second, calc, number 5, press enter 3 times, and it should give you your one of the intersection points. So the far left one's -4, 1. And then you'll have to repeat these steps and move your cursor to the other intersection point, then press enter 3 times. The other one should be 2, 7. So I want you to plot those points. Two 7's the other one. So if you're looking, you need to look at your graph on your calculator. It's going to look like this for your parabola, and then your linear should be here. So your solutions are -4, 1, and 2, 7. So again, when you solve a system, which are 2 or more equations, you're finding the points of intersection, which is the points they have in common. Okay, let's take a look at the back. So on the back, we're going to be given 2 equations again, but this time we're going to use substitution instead of graphing. So we're going to solve the linear equation, which is the one that just has an x. So we're going to get y by itself on the linear equation. And then we're going to substitute the linear equation into the quadratic equation. We're going to simplify it and solve for a variable. You're going to substitute the values found in step 3 into either equation to finish finding your solutions. All right, so example 3. We are going to first solve our linear. So we know this one's the linear one. So I'm going to subtract 2x over, and then I divide by -1. So that's y equals 2x minus 7. So I solve for y, and then now I'm going to substitute that in for my y on my quadratic equation. So I'm taking this, and I'm going to substitute it in right there. So whenever I do that, I'm going to have 2x minus 7 equals x squared minus 8x plus 14. Notice this is still a quadratic equation. So what we need to do in order to solve a quadratic equation, we need to set it equal to 0. Now, remember we've discussed all the ways to solve a quadratic. We can use square root method, which it won't work on this one. We can use factoring. We can use graphing. We can use quadratic formula, completing the square. So remember the one that we discussed, quadratic formula works every time because sometimes we don't have real solutions, sometimes we have imaginary. So let's use quadratic formula. I'm going to set it equal to 0. So that's 0 equals x squared minus 10x plus 21. Okay, so again, if you want, you can use quadratic formula. That one works every time. You could also, this one actually factors, you could also factor it. So your choice. I'll just keep it consistent and I'll just use quadratic formula because I know that will work. So plugging into the quadratic formula, let me write it down first. Okay, so negative b, so that would be 10 plus or minus the square root of negative 10 squared minus 4, a is 1, c is 21, over 2 times 1. So remember we discussed quadratic formula before the break. We need to plug in what's under the square root without the square root symbol. And you should get 16. All right, so when I plug in, notice 16 is a perfect square. It equals 4. So remember we discussed also before the break, if you no longer have a radical, you need to find your 2 solutions. So you're going to have to add and subtract 4. So 10 plus 4 is 14 over 2, which equals 7. 10 minus 4 is 6 over 2, which equals 3. So I found the 2 x values. So whenever I have my x, because that's what we solved for, we're going to substitute that in up here, and then that should give us our y. So when x is 7, That's 14 minus 7, which is 7. So there's a point, 7, 7 for the solution. When x is 3, I need to substitute it in. So that's y equals 2 times 3 minus 7. So that's 6 minus 7, which is a -1. So there's my other point, 3, -1. So I found both solutions. So if you were to graph it, those should be your 2 points of intersection. So this is just another way of solving a system, a linear and quadratic system. You can use whatever method you want to solve your quadratic equation. Okay. All right, so now on this one, so we're going to substitute our linear one into the quadratic. Notice this one's linear. It's already got y by itself, so I'm just going to go ahead and substitute it in for the y. So 10x plus 50 equals -5x squared plus 20. Again, I have a quadratic equation. It doesn't really matter what side you move things to. So I will go ahead, I'll just make my x squared positive. So I'll add 5x squared and subtract 20. So that's 0. 5x squared, that's going to be plus 10x, and then plus 30. So once I have it set equal to 0, I can use the quadratic formula. You can reduce it if you want. Notice I can divide all of them by 5. You don't have to, but you might want to make it a little easier. So I'm going to use this instead. So I just divided all of it by 5. And this is really not necessary, but I wanted to show you that these are equal. So I'm going to use this and plug into the quadratic formula. So I have x equals -b, so -2 plus or minus b squared minus 4, a is 1, c is 6, all over 2 times a. So again, after you've used the quadratic formula, make sure you're typing in the part under the radical without the square root. You should get -20. Remember, we discussed before the break, if we have a negative under the radical, that means it's imaginary. So on the graph, there would not be points of intersection because it doesn't intersect there. So we're just finding our x values here. So I'm going to bring out the negative and put an I and then square root of 20. I need to see if I can simplify it. So square root of 20 is not perfect, but I can use factor tree. 2 times 10, 2 times 5. So this is -2 plus or minus. I'm going to bring the 2 out because I have a pair. So 2i square root of 5 over 2. Now, remember we talked about reducing. We can only reduce if these outside numbers can be. They can all be divided by 2. So that's -1 plus or minus I square root of 5 equals x. And we're not able to plug that back in and find a y value because remember, graphically, there wouldn't be a real solution, which means they do not intersect there. So you can just write your answer as your imaginary solutions there. Okay, if you have any questions, please let me know.